Ever wondered what unleashes the fury of a volcano, turning calm landscapes into scenes of fiery mayhem? It all begins deep beneath our feet, with a substance called magma. But what exactly is this molten rock, and how does it power such incredible explosions? Let's dive in. Magma is a complex mixture of molten rock, suspended crystals, and dissolved gases, all stewing together under immense pressure and heat. Think of it like a bottle of soda, but instead of sugary water, it's liquid rock. And instead of carbon dioxide, it's a mix of water vapor, carbon dioxide, sulfur dioxide, and other gases. Just like that soda, as long as the cap is on, or in this case, as long as the magma is deep underground, the gases stay dissolved and everything is relatively stable. The real action starts when this magma begins to rise towards the surface. As it ascends, the pressure drops dramatically. This is the moment the cap comes off a soda bottle. The dissolved gases can no longer stay dissolved in the liquid rock. They start to come out of the solution, forming tiny bubbles. Now, the composition of the magma itself plays a huge role in what happens next. If the magma is thin and runny, like honey, the gas bubbles can escape. This usually leads to a less dramatic eruption, where lava flows gently out of the volcano. We call these effusive eruptions. They're still dangerous, but they're not the explosive kind we often see in movies. But what if the magma is thick and sticky, more like peanut butter? This is where things get explosive. This type of magma is high in silica, which acts like a thickener. When the gas bubbles try to form and escape from this viscous magma, they get trapped. They can't move freely. As the magma continues to rise and the pressure keeps dropping, more and more gas comes out of solution, and the trapped bubbles start to expand and merge. Imagine thousands, 10 millions, then billions of bubbles, all growing larger and larger, crammed together inside this thick, gooey magma. The pressure inside these bubbles builds to an unimaginable level. The magma is essentially being inflated from the inside out, stretching and straining until it can't hold together anymore. This is the tipping point. The magma shatters. This rapid, violent fragmentation is the heart of an explosive eruption. The force of the expanding gas bubbles blows the magma apart into countless pieces. These pieces are what we call tephra. Tephra isn't just one thing. It's a catch-all term for all the solid material ejected during an explosive eruption, regardless of size. It can range from a fine, powdery substance called volcanic ash, which can travel sand of miles and blanket entire cities, to larger, pebble-sized fragments called lapilli. And then there are the big ones, volcanic bombs and blocks, which can be as large as cars and are thrown out like cannonballs from the volcano's vent. This cloud of superheated gas and tephra, known as an eruption column, blasts upwards into the atmosphere at hundreds of miles per hour, reaching heights of over 20 miles. It's a terrifying and awe-inspiring display of nature's power. It's this process, the trapping and rapid expansion of gas bubbles and thick, viscous magma that turns a quiet mountain into a source of pure mayhem. So, from the quiet depths where magma is formed, to the violent fragmentation caused by escaping gases, the journey of magma is what dictates the eruption's personality. Whether it's a gentle ooze or a catastrophic explosion, it all comes down to the chemistry and physics happening miles below our feet. The science of volcanoes is a constant reminder of the dynamic and powerful planet we live on. Thanks for watching. If you found this journey from magma to mayhem interesting, do you want to forget to hit that like button and subscribe for more deep dives into the science of our world. See you in the next video.